Hi everyone, I'm Chen. This is a joint work of Indiana University Bloomington and Institute of Information Engineering Chinese Academy of Sciences. And in general, code analysis is one of the most widely used to discover software vulnerabilities. But it is hard to find logical vulnerabilities because a deep understanding of the system's logic is a prerequisite. So at a code level, absolutely, it is too difficult to recover. However, a system's documentation is a great source. Some may already provide accounts of how a system is designed or how it should be used to remain secure. So in our work, we want to explore the full value of the documentation. We want to study whether the documentation already carries abundant information to help identify a logical vulnerability, even without touching any code. And in previous time, discovering logical vulnerability cost a lot of manual work. So in our work, we also want to explore the direction to automatically discover logical vulnerability. Our first step has been made on the payment syndication service. It encapsulates the various third-party payments and simplifies the merchant developer's workload. Let's look at how the payment syndication works. This is a common payment process. When the buyer is going to pay an order, at first, the merchant will generate a third-party payment credential to him. Holding the credential, the buyer pays the order to a third-party payment, and then when he finishes the pay, the third-party payment server will notify the merchant payment result. And to keep the payment process secure, in the third-party payments documentation, there are some security requirements. They ask merchant developers to do some security check at a specific status in the payment process, such as PayPal. In its guidance, it says when the merchant developers receives a notification message, they must check whether the payment currency is a correct currency for the item. If the merchant do not check it, the adversary may shop a product at an arbitrary lower valuable currency, such as using the Chinese RMB instead of the US dollars. So to simplify the workload of the merchant developers, the syndication places a new party involved in the payment process to help the merchant to comply with the third-party payments. For example, instead of preparing the third-party payment credential by the merchant, the syndicator replaces the merchant to do so, or to help the merchant analyze different structural notifications from the third-party payment. The syndication asks the payment server to send a notification to him directly. And then after he interprets it, he restructures the notification in a uniform form and notifies the merchant eventually. And for the previous security requirement, naturally, when the syndication encapsulates a third-party payment and helps merchants to do their work, of course, they should be still fulfilled, right? Either by the merchant or by the syndicator. But if both of them have no way to achieve the security requirement in the new payment process, we think this would introduce a design-level logic vulnerability in the payment syndication. For example, for the security requirement of the PayPal, if in the new payment process, if both of the merchant and syndicator don't have the visibility of the security requirement related data. For instance, the syndication don't know the ground truth to check, and the merchant doesn't receive the currency from the notification, then there is no one else can fulfill the security requirement. And attackers can shop the product at an arbitrary lower valuable currency, like just mentioned, using Chinese RMB instead of the US dollars. So here, all the information we just mentioned are already distributed in the payment syndication's guidance. For example, at the screenshots from the real-world syndication's development documentation, it uses a diagram and text description to describe each transmissions in a syndication's payment process. For example, here's a sentence: syndication will send a payment result to a user server. It exactly describes the notification transition from a syndication to a merchant as highlighted in the left figure. And in the implement interface screenshot from the syndication's documentation, it explains every parameters the merchant will receive in the notification from the syndication. But after scanning them, we find there is no current currency parameter in it. That means the merchant doesn't receive the payment currency, and so he can't achieve the security requirement. In the payment process, the syndication doesn't receive the ground truth too, so it can't achieve the security requirement either. So when a shopping app use this payment syndication, a money buyer could achieve buy a product with lower value currency by PayPal. And furthermore, even the merchant has the visibility of the security-related data. If they have not been informed to do so by the syndication, they may still miss to implement a security check in their code and introduce an implementation level logic vulnerability. Because while using a syndication payment service, it is easy to understand that the merchant developers will develop only by following the syndication's guidance. So for the syndication, a simple way to inform the merchant developers the security requirement is to document it in their developer guidance. For example, as the screenshot shows, there is a security requirement description in the syndication's developer guides. Users need to verify whether the signature is correct and verify the payment amount equals the order price. The two verifications must be performed. So for supposed security requirement of a merchant in a syndication's payment process, if there is no responding security requirement description in its development documentation, this may introduce a likely implementation level logic vulnerability. So next, the technical challenges in our work comes to how to extract this information from the payment syndication's document. In our work, we come up an effective method leverage current NLP techniques to extract them creatively. And since the time limitation of the presentation, so here I'll only introduce the first one, how to extract the payment process here. Please see more technical details in our paper. So for the payment process, we use the FSM finite state machine to formalize it. As shown in the figure, each node represents a state of the party, such as a buyer, the merchant, the third-party payment, and the syndicator. And each edge represents a transition that the party of the former state sends a message to the party of the later one. Since the syndication payment service is going to help merchants to do their work, and we can view its FSM as an extension from the third-party payments, as shown in the figure. The syndication replaces the merchant to receive the notification from the third-party payment directly, and then send to a merchant after he analyzing. So a new state W2 has been added in the syndication's FSM. We can view the blue sub-FSM as an extension from the red sub-FSM. So to build the whole syndication's FSM, our idea is to come up with all the extension structure first for each merchant state in the third-party payments. For instance, here, for the MF state, we come up with 3 possible extension structure. The first one, the original, keep the original process, the syndication do nothing. And the second, the merchant receive the notification and forward to the syndication to analyze. And the third one, the syndication receives the notification directly and then send to the merchant after analyzing. So next, we extract all the transmission sentences from the syndication's documentation to determine which extension structure the MF state has been used. Because different, as we can see in the figure, different extensions have different edges. Here, we extract these transmission sentences by their predicates, such as here, the receive. And then for every sentence discovered, we need to find who is the sender, the receiver, and the content of the message. So we use the NLP technique dependency parsing to determine the semantics. For example, here, for the sentence, the syndication receives a payment result from Alipay. After analyzing its dependency relationship, we can determine for the predicate receive, the subject of it is a receiver, and the direct object payment result is a content, and the indirect object Alipay is a sender. That exactly describes the notification transmission as the figure showing in the third extension structure. So we can determine the state MF has been extended by the third structure. By this way, we can build the payment syndications FSM automatically. And in our work, we develop a tool called Dilution. We use it to analyze 8 real-world syndications guides. All of them are popular and with tens of thousands merchant developer users and hundreds of millions buyer users. Our tool reported 2 design-level logic vulnerabilities and 9 likely implementation vulnerabilities. For the design vulnerability, both a syndicator called Fuchena and Big Cloud, they do not have the visibility of the third-party payments secret key. So they can't verify the signature of the message from the third-party payment. And in the meanwhile, they do not forward the whole message to a merchant. So the merchant cannot verify the signature either. So the adversary could forge a fake third-party payment notification to cheat him an order has been paid. In our experiment, we explored these vulnerabilities in real-world apps and achieve shopping product for free. And for the implementation vulnerability, we find some syndication guidance do not inform merchant to check the payment amount or the payment currency as a third-party payments demands. So we randomly choose apps to exploit. In Trust App Plus, in these apps, we find all the merchant developers really don't miss to implement a security check in their code. So we can achieve shopping a product at a arbitrarily lower price. Finally, let's summarize our contribution. The first one, we provide a new direction. We explore the potential to predict a logical vulnerability just from the documentation only. Our preliminary study on payment syndication service shows this is indeed feasible. The documentation already contains enough information for us to help identify the logical vulnerability directly. And we believe the research along this line could bring new perspective to software security analysis. And we hope we will see more study on this line to enable the vulnerability detection more efficient and intelligent. And second one, we provide a new technique. We developed a Dilution, the first semantic-based documentation analyzer. It can automatically inspect a developer's guidance and infer logical vulnerabilities. And our code has released on GitHub. Welcome everybody use it. And finally, we have some new findings in the system, which has already been studied for several years, the payment process. We find security critical logic vulnerability in the payment syndication process. We can exploit them to achieve shopping a product at a arbitrarily lower price or even completely for free. And we report all this vulnerability to the corresponding companies, and all of them acknowledge them, and thanks to our effort. That's all. Thanks for listening. Welcome question.
Thank you, Chen. Any questions? Again, please step up to the microphone and state your name and affiliation. So I think I'll start. You reviewed many different payment platforms.
Yeah.
And they are all with their own documentations, yes? But
sorry.
they all came with their documentation, which you analyzed. But I was wondering if these payment platforms also came with sample apps or source code which shows how to use them, and whether you analyzed that code as well.
Sorry, could you say it
So
again?
when you analyze the documentation,
Yeah.
is there together with the documentation also some source code, an example source code of using this payment platform? Did you analyze that source code as well?
Yeah, we have checked the. They have some example in in a syndication payment, except for not only the description will tell the developers how to use it, and there are also some example. But we find there are still they don't explain it clearly in the example, and their code. We even find some in the code there are indeed the logic vulnerability we discovered. Yeah.
Okay, thank you.
Thank you for the talk. I'm Jitin from IIT Madras, India. So I was just trying to understand.
Sorry, could you speak louder?
Yeah, I'm just trying to understand your testing process. So my question is, did you test actually the backend of the third parties? Because is there any, can you make a differentiation between the guidelines that are provided to the merchants from the documentation? Okay, let me put it better way. Are you sure that these requirements are not tested at the back end of the third party?
Sorry, I didn't catch
For
the
example,
question.
if you take the case of different currencies, have you tested if these verifications are not done at the back end of the third party? Because the development documentation of a third party could be confidential and may not be available to the public.
I'm sorry, can I?
My question is.
So one moment, my co.
Yeah, I think, excuse me, I'm also the author of the paper. Yes, we did. So we performed end-to-end test on those, against those vulnerabilities, and we confirmed, yes, the merchant did follow the incomplete, insecure documentation, and their backend are indeed vulnerable due to that, due to the problem. Yes.
Okay, thank you.
Okay, so let's thank Chen again for the talk.
Thanks.
And